So the first thing we're gonna need is int main, right? So let's do. Do we want to make this kind of like a demo program like last time? I think that might be a good way to do it. So, you know, int main, and it's the number of arguments in the arg string. So int arg. Do we want to do num args, or we want to do like arg num? I don't know. How about NOA, number of arguments, and int arg array. I don't know. And actually, this is a char pointer arg array. Let's just do this. AA. I just don't feel like typing stuff, so AA, arg array, NOA, number of arguments. Keep it kind of terse. And then, you know, just printf, you know, whatever. And we'll put something more meaningful here once we get started here. We'll have to include the library for printf. And we're also going to need, what else are we going to need? We're going to need, I believe, int2a, but I don't know I2a, I believe. If we're going to use it as a command line utility, we need like a to I. So include a to I. I don't even know if I have such a thing here. Integer to ASCII. No, actually, no. I actually want the other thing. Thank you very much. But this was a while ago, so let's actually look up what that is. So to get the command for that, so A to I, C99, right? So there's most likely a utility function for this already because Golang has it, and Golang is just a modern C. So yeah, A2I, right? So it's going to turn it into an integer, type int, so it's going to give us 32 bits. Now the question is, where the heck is it? It could be anywhere. So it's great that there's an example here. I like that. You know, it'd be nice to tell me what library it's in. So that makes me want to swear a bit. Because it's like, well, I gotta take, this onesie is getting hot all of a sudden. Yeah, this is ridiculous. The most annoying thing I have with tutorials, which hasn't changed in the past 10 years or so, is, hey, here's this tutorial how to do this thing, and we're not going to tell you what the includes are. Technically, they are kind of telling you what the includes are, but they're not telling me specifically what library that comes from. You know, my guess is that it's coming from string.h. So let's roll with that and say, yeah, it's probably in string.h. So we'll say, you know, we'll take this guy here and we'll say A to I, right? And then we might as well, since we're going to do this, we can also do this, you know, for printf, right? Okay. So the first thing is just, you know, int, I don't know what we want to call it. Num equals A to I, and then we'll take the argument array, and we'll take argument number 1, if there is an argument number 1. So there might not be, so we might want to change this around a little bit. And say that, you know, the number equals this, but only if the number of arguments is equal to 1, or actually if 2 equals the number of arguments. And we'll do the same thing we did last time. So if we don't have exactly 2 arguments, we're just going to say printf expect exactly 1 user arg. I don't know. Let's not make it too let's not make it too crazy here. Right, I just want a little note to say, you know, give me exactly one argument. And then I just won't do anything, right? And this printf, we can get rid of this. What else do we want to do here? I think that's enough to get started. Let's save this somewhere. So let's go into our R drive, go into our Git repos, go into the kanji coder repos, and let's call this, I like something that would be 7 letters, so bin, and then pri, binprin. That's kind of weird, but you know what, we'll go with it, binprin, for binary print. Binary, yeah, sure, binprin, whatever. So we'll call this binprin.c11, and then we're just gonna do our standard kind of, well, ooh, that's a little bit too light. That's a little bit too heavy. HKMFC11 light. Do we have like a light version that's not so crazy? HKMFC11 mini. Okay, that's a good build script. Okay, let's go with that. So I know it's like, hey, why don't I just write this out by hand? I'm like, nope, I'm just going to use something I already have. So, right, this is the GCC command. We're going to compile as C code. So whatever the file supplied is, we're going to compile it as C code. So X means the language. The language is C. What are we compiling? Well, we're compiling pebbase.c11. Well, we aren't. We're compiling binprin.c11. God, we got to save this. Binprin.sh. So we'll name it the same exact name except sh because it's going to be our build script for this. -o means the object file name, or the output file. Alright, so object file.o. I believe if we didn't give this parameter, it would just be o.a or something like that. And then just a whole bunch of like specific warnings and configurations that I like to be a little bit stricter. Let's get rid of that. And that looks good to go. Let's go with that. Let's open up this in Explorer here. And why don't we give the first run of this a double click, but then after that we're going to run it in the console so you can kind of see how that is working. So if we double click this, and if we didn't make any stupid mistakes, which I guarantee we probably have, implicit declaration of function A to I. So you remember that tutorial, that little thing where we're like, hey, tell me what, you know, A to I, so C99. So here's A to I, and you would think, oh, string.h, that's where it would be, right? So I guess not, and this is why, like, you know, maybe the, I'm not supposed to swear on this channel, so I guess I should just say that the people who wrote this tutorial should go die in a fire. You know, maybe I'm tired, but it just kind of seems like they don't tell me which library this comes in. So I'm going to guess it's stdlib. That's my next guess. Yeah, I'm going to guess it's an stdlib. That's my next guess. But it would be nice just to be told in the introduction to this, right? I think the most basic thing we want to know is, you know, where the heck is it? Unfortunately, with a lot of, like, C code, when it comes to some of the more common functionality, you just have to know where certain things come from because they're not namespaced. And it's kind of one of the reasons why I namespace my code so heavily is because not knowing where certain commands come from annoys me. Now, I get the idea that we don't want to type a huge namespace in front of printf when we use it all the time. Probably same thing with a lot of these other functions, where you just don't want to be inconvenienced. But the thing is I'd rather be inconvenienced because you're going to read the code a lot more than you're going to write it. So I don't care if it's a little bit more difficult to write the code. Anyways, so we're going to give that a shot and see if that's where A2I is. Or see if the compiler is going to complain. Nope. Okay, so set but not used. Okay, we're making some progress. So now we're going to do bin prin. And we'll say the name of this is binary printf of this tutorial. So let's just call it binary printf, right? Now we could do printf binary, but we already kind of said that we're going to name this lecture is kind of named binary printf, so let's just go with that exact name and then give it that number value and then create a function above this for that functionality. So we'll just do like a void, and here's the number, int num in there, and then we'll do some logic and make it all good and whatnot. So for now, let's just do printf and say num not bin, and you know, %d\n, and just do that, right? So we're gonna get to printing it as binary, but let's just stub something in just to get this working as quickly as possible. And once we have it actually working, then we'll worry about it. So it says give one arg because the build scripts I usually have actually run the program right after they build them. But in the case of what we're doing today, we want to supply arguments, so we really don't want to do that workflow. So we're going to go into this script, and where we're removing the executable right here, and even where we're running the executable, we might want to say just comment both of these out. So leave the removing and the running to me, but just build it, right? So build it and remove the object file. So let's take a shot at that and see what happens now. So if we double click this, right, we just see enter to exit, we hit enter, we exit, we see we got exe.exe now. We can go git bash here into this folder, and if we do that, we have a nice little terminal here. Let's scroll in here, because I know that it's not going to be very big on, if you're watching this on Twitch or YouTube. I don't want you to have to full screen to get this to work. So let's just scroll in here and do /binprin no, we called it exe.exe. It's still called exe.exe, isn't it? Hold on. ls. And yeah, it's still called exe.exe. Well, we're going to change that, but let's just, because it is exe.exe, that's what we'll use, right? And we'll supply like the number 2 or something, right? And then we see number not binary 2. Excellent. So the code is working. And let's exit this terminal and mess with this build script a bit. So we're calling it exe.exe. It would make more sense if we just call it binprin.exe. So wherever we're using exe.exe, we're just going to go binprin.exe. And we're just going to paste that there. And now our build script is all ugly. And we can try to make it look a little bit nicer, so it doesn't look like we just hacked it together. There we go. Okay, let's double-click this to run the build script to generate the executable with a name that matches all the other files. And let's git bash here into this folder. Let's maximize this. Let's zoom in here. Let's do a ./binprin.exe, and then let's choose like some other number. And we can see, okay, there. So we got a little console thing working. Let's exit from here, and let's start writing the rest of the logic. Okay, so how are we going to print off the binary? Well, first of all, we got to remember that an integer is just a 32-bit value. And let's actually kind of divide this and say binary print function. So I'm going to create like a little section for the binary print logic. And we're going to write some macros and stuff to just get this kind of organized. I don't really like to use a type called int in my code. I usually like to have a bit width type. So let's do define i32, because it's going to be an int32, and then down here we're going to undef int32. And then right here, we're going to call this int32. And over here, we're going to call this main func, right? Just make a section for the main function. The main function has to be beneath the other functions because the main function inadvertently or directly calls all of the other functions that are going to be in the file, and we're not using any for declarations. Therefore, the main function always has to be at the bottom. Okay, so this is all nicely organized. Let's steal these defines and paste them down here as well. So define it, undefine it. I like all of my defines to be local to the section of code that I'm working on, because if you don't contain them, they end up just spiraling out of control and getting to a critical mass, and it just gets ridiculous really quick. So this may seem a little bit redundant that I have this here and I also have it here, but just trust me, it gets out of hand if you don't do it this way. So anywhere that we see int, we're just going to do int32, right? int32, 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 and after that, we just need to kind of figure out how we're going to loop through the binary, and I don't know, for int32 I equals 0, and then I is less than or equal to, 32 minus 1, and, I plus plus, and then now we got a loop, right? And then after we loop through here, we're going to loop through every single bit, so we're going to take the number, and we're going to shift it over by I, right? The first time we're not going to shift it over by anything, right? Because it's going to start off at 0. And once we shift it, we're going to have to mask it. So we're going to have to be able to get 1 bit. So we can just mask it with the binary 1. And that will give us a 1 or a 0. And we should make a variable called, I don't know, I don't really think that this should be a int32 here. We should have a, let's just say u32, u32 num. We could do that, or we could just be really lazy and just call it u32, u32, right? Because technically, right, the casing is different, so we can get away with that. Define u32 here, and then down here we're going to undef u32. Align this a little bit better, and once we've done that, what we're going to do is assign this. So this is actually going to be assigned to u32 cast of whatever number we inputted into there, right? So now I'm not familiar with bit shifting with assigned values, but it doesn't sound like a wise decision to me. If we're going to do bitwise stuff, really we should be working with unsigned values. So I don't really care about printing negative values. I don't really care about that. If it's something you care about, well, then maybe you can leave it to exercise to the reader to modify this. So now that we have this u32 value, instead of this number, we're going to shift this over, and we're going to have another u32 called bit, or really we could name it, we could make it a u08 if we really wanted to. I think that would work. No, let's just keep everything consistent and normalized. Let's just say, we'll call it bit, and the bit equals this nonsense over here, right? So we're going to shift over the number by so many numbers of bits depending on what the current bit index is based on this loop, and then we're going to mask it. Now, we got to think about how this is actually going to stack up when we are printing it off in the console for a second, and subsequent printf commands are going to make characters further and further to the right. If we don't do a new line, right, the next character is further to the right than the previous one that was printed, right? So right now we're starting at 0, but 0 is all the way on the right, and we really want to start from the left. So what we need to do is we need to change this, and we need to change this around to 32 minus 1. It's going to be the start value, and I needs to be greater than or equal to 0, right? And then greater than or equal to 0, and I minus minus. So we're going to go in the complete opposite direction, and because we're using a signed value, we can actually get away with this, because we would not be able to get away with this with a unsigned value. Yeah, we wouldn't be able to, because this would just overflow and end up being a ridiculously high number rather than going negative. Okay, so once we have this bit value, all we got to do is do a... we should actually go up here for a second and do... Well, no, let's not do that. Let's just get it done first, and we'll polish it up after we've got it done, right? So we're going to printf the bit, and all we got to do is say %d, and then that's %d, and then, right, just the format string, nothing else, and then just the bit value, right? And that's all we got to do. And then maybe down here, right before we exit, we should probably do a printf and then a \n, a new line, so that whatever number we print off ends up on its own line, right? That kind of makes sense to me. Let's give that a run and see what happens. So first thing we're going to do, we're just going to build it, see what kind of stupid mistakes we've made. Unknown type name, int32 type. So we have to include the header that has int32. So we're going to include i32. Well, I don't really mean define i32. Include uint32. There we go. It's really for uint or whatever. Uint32, int32, right? It's for these types here. Okay, cool. Save that, give that a run again, just double click that build script, see what we can get going here. Enter to exit, okay, and let's get bash here. Okay, so I've been doing this clicking around kind of stuff. From now on, we're not going to click around, we're just going to keep this console open. So /binprin.exe, and then, I don't know, some number, right? Okay, so we got this binary. I'm fairly certain that that's right. Now, we could take this and double check ourselves really quick. We could open up a calculator here, and if we go into binary and we do a... Can we do Control-V here? Yeah, we can do Control-V, and the decimal is 8,372. What do we got here? 8,372. Okay, so we've just done the thing that I said we were going to do. What else are we going to do about it? Are we going to clean this up? What do we want to do? Well, a big string of 32 bits is very, very difficult for me to understand, I'm going to say. So, what I would like to do here is make this a little bit easier, kind of like put some separators in here or something like that. So, after the fourth whatever, I want to put a divider, and after the fourth whatever. So, what we're gonna do is we're just gonna do a naive solution here. We're gonna say, I don't know, counter for dividers, right? And we'll just say, you know, cow ++, and you know, if 0 equals cow modulus 4, right? So if it's divisible by 4, 1, 2, 3, 4, right? If it's the fourth thing that we have printed out, then we are going to do like a little printf of some type of divider, right? So maybe a divider like this, and we'll still have to work out the kinks in this, but this will be a good starting point. Let's go over here and let's rebuild, right? So we'll take where are you? Oh, I guess we're not going to. I guess we're just going to do ls, and we can see we have binprin.sh there. So binprin.sh, use that to build, and /binprin.sh. You got to remember that this is a Linux terminal. You got to do /. It's not like a Windows command prompt. Okay, and then clear, and then /binprin.exe, and then some number. And we're getting a little bit better here. So we have these numbers. However, we see everything is kind of misaligned here. We have like 1, 2, 3, and then the divider is like right there, right? That's ugly. That's not what we want. You know, I thought I was better than this, but I guess not. So why am I screwing this up? Oh, because this print statement is in the wrong order, right? So, you know, I'm going to align this up over here, even though this might look ugly, so that I know I have these two print statements. I don't know, maybe it's a bad idea. Whatever, I'm doing it. So let's take that for a roll. So let's go up and see if we have the build script. Take that build script, clear, hit up a few more times for, yeah, let's try this again. And there we go. So now everything is kind of like nicely divided, but you'll see that it's not quite right because we have some asymmetry here, right? We got like this bar right here on this side, but then on the other side we don't have the bar. Now, do we want to remove it from both sides, or do we want to include it on both sides? I would say neither. I would kind of like maybe square brackets. Actually, nope, not square brackets, because square brackets I use for hard-coded strings, and this is procedurally generated text up there, so no square brackets. Maybe some bubble brackets, also known as parentheses. So let's first just work on getting rid of this last thing here, right? So everything kind of breaks down when so you know what we can do? We can just say, let's say that, you know, if it's divisible by 4 and you know, I is not, and 0 is not equal to I, right? Right, divisible by 4 and it's not the last thing, right? And if we do that, that's probably all we need to get that working. So let's build our thingy and give it another shot, right? So give that a shot, and that looks a lot better. Now, I would still like a little bit more stuff. I would actually like to see each byte, right? So this is 1 byte here. So I would actually like a little dash between these, bars between the bytes, but then dashes between the individual nibbles of 1 byte. I think that would be much more readable for me. So how are we going to do that? Well, it could be, it's an every other thing, right? So it's dash this, dash that. It's every other thing. And because it's an every other thing, we could do like, I don't know, we could just do, you know, U32 EO, EO, and call this one every other. And then, you know, I guess every other equals 0, and, or actually we could set it to 1, and then EO equals not EO, right? I believe you can just flip it to make it 0, 1, 0, 1, 0, 1. And the first time we flip it, it's going to be a 0, and, you know, we'll say that, you know, if EO or 0 equals EO, sorry, I keep on doing that. If 0 equals EO, then we're going to printf a little dashy dude over here. And otherwise, and you know what, I don't care about performance here, so I'm just going to write it in a way that is easier to read, so I'm not going to worry about the else. If 1 equals EO, then we're going to do this. So in one case we do a dash, in the other case we do a bar, right? So if we get this wrong, then we just got to flip it around, but whatever. Let's just run it, and we probably got it right, but we'll find out pretty quickly, won't we? So clear, and then if we do this, run the script again. Okay, cool, awesome. So we got like the first byte, the second byte, third byte, and the fourth byte. Now, the disadvantage of having it like this is that, you know, we can no longer take this and shove it into a calculator, right? But the thing is that I don't really care about shoving this number into a calculator. I want this so that when I am looking at bits that I'm kind of bit packing, that I can observe them and be like, hey, what the heck is going wrong here, right? So So we're pretty good here, but we need to do a little bit more cleanup here. It would be nice to have just a little bubble bracket on the beginning and end. So I think, to do that, we could just do a printf and do one of these on this side. And oh god, let's put some spaces here, because that is very hard to read without any spaces. So yeah, so right here I'll put a printf, and then right over here we'll put a printf. And we do want some, like every time we, actually no, that'll actually look good. That'll look good. So let's take this, let's clear, let's rebuild the executable with the build script, and then let's give it a roll and see what we got. So that looks better. I still would like one space between each one of these, a little space here and then a space here, and then I would say we're good. So let's go do that, and then I think we're pretty much done writing this. So right here we're just going to add a space, and then right here we're going to add a space, and then I don't know what we're going to do here. This looks kind of ugly and scares me, so I don't know, maybe we'll try to make things better and do that. Yeah, sure, why not? So clear, find the build script, run the build script, hit enter to exit the build script. The build script was meant to be double-clicked, that's why there's that enter to exit to like pause the console. And if we give this a shot now, and oh, look at that, it's beautiful. So now we have a little executable where we can just go .binprin .exe, and then we can just type some random number, and then we can see what that looks like in binary, right? So if we want a full 32-bit value where we can see binary in all of these, then we would really want a hex value. I don't know if int to ASCII does this, but hey, let's give this a shot. So binprin .exe, if we do like a 0x, does it understand us? So like a ff, does that work? And the answer looks like no to me. Dot slash bin prin .exe 0x ff. Let's try that. Okay, so absolutely nothing. So I'd say that int to ASCII doesn't really work with hexadecimal, or I don't know how to use it. So let's actually try to get that to work with hexadecimal, because I would really like to use it on the command line where I can input a hex value and still get that code to work properly. So let's go to consult the internet, the wise internet, and say it is A to I hexadecimal C99, something like that, right? A to I from hex representations. That's definitely what I want. Need to make like something like str toll. Maybe that's what I want. Try to use strtol. No, it also works with a 0x optional, blah blah blah. So 16, the base is 16. Okay. So now I don't know where the library for the, oh, there we go. Let's open up this. Now, does strtol work with, well, we'll figure it out. Uh-huh. Is it an stdlib? Is that where it is? Let's just give that a shot. So we think that it's probably an stdlib. So let's just take this guy here and let's just shove it in, right? Let's just be like, hey, instead of that other thing, let's just use this thing, right? So instead of this A to I, let's just comment this out and try to use the other function and see how that kind of works for us. So this is the argument we want, and it needs to be right over here, and then it's going to be, well, we don't want it as a 16, we don't want it like that all the time, do we? No, can we just supply null? Can we just supply a null here and then get it to work? I don't know, let's just, you know, can it look at the context and to decide what to do here? I don't know, let's try it. Let's try to just do 0 and 0 and just see what happens, and I don't know if that'll work, but let's experiment and see if that is going to be fruitful. So enter to exit, and I guess it didn't complain at us, so that's a good sign, I guess. Let's do 0xff, and hey, look, that's the thing. Excellent. How about if we do that again, but we do like a let's do something that we know is 2 set 1s, so like a 3. And excellent, excellent. So, so that works, right? Because I didn't want to hard code it as 16, because I don't want the radix of 16, so I just supplied 0, and that seems to have worked. Now, I don't know if that's like the way it's supposed to work, so let's check out that last parameter for a second and see if, int base. So if we look at base, is base like optional? If the value of base is 0, the expected form of the subject sequence is that of a decimal constant, octal constant, or hexadecimal constant. Yeah, so if you use a base of 0, it's kind of like it's going to use context clues to determine what the base is. Okay, so that's what I was kind of thinking there. Excellent. So looks good to me. Let's do one more test, though. So let's take 0x, ff, 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 ff. So that should be all 1s. Let's make sure that works. Yep, all 1s. Excellent. Ooh, hold up. We're a little bit off here. I see a 0 here. And 1, 2, 3, 4, 5, 6, 7, 8. So that's not quite right. So now the question is, why is that not quite right? So let's take this number and copy it, because maybe there's some type of signed thing going on. I don't know what could be going on. Let's just open up the calculator here and try to figure out what's going on here. So that is a decimal value, so let's go to decimal, and let's go Control-V to paste that and see what we got. Yeah, so we have like one missing bit here. So all of these are set, but this bit here is not set, right? Because we want all these FFs, and we're not getting that. We're getting, one of them is missing. Now, did I just type it wrong? Can I just not count here? 1, 2, then another 2, then another 2, and then another 2. So that is weird. The best I can think of is that it is, oh, you know what? I know what's going on. I'm just being stupid, right? Am I being stupid? I'm pretty sure I'm being stupid. So this number is the int32. It does not have the range. If we really want to do that, the number needs to be a uint, right? And then this binary printf here, is it taking a int32? Well, it's not taking an int32 anymore because it needs a u32 to get that whole range. So u32 number, and then this cast here, no more cast. In fact, this u32 here, we can just say that this is number, right? We can just get rid of this middleman altogether and give that a shot, and then hopefully everything will work again. So /binprin.sh to build, and unknown error, unknown type name, u32 num. So it looks like I have not properly capitalized some things here. So where did we screw up here? U32 number, right? So it's input there. Unknown type name, U32, on line 43. So it's not where I thought I was looking. So U32 number, oh yeah, so we need to copy these defines really quick. So I'm going to paste this over here, and then take this guy over here, and we're going to paste it down here. Okay. So let's clear, and then try to rerun that really quick. And then /binprin .exe. Let's just do something short for now. Let's do it one more time, and then 0xff, FF, 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 hit enter, and we are still in trouble here, huh? So we were expecting, so something about the range, and maybe it's just because maybe there's the possibility that this isn't returning the proper bit width. Does this take the proper, so U32 here. We got this number here. I mean, that looks good. So all that looks good. So is this not returning a, it's probably returning a signed value maybe, and we don't really want a signed value. So let's go look at the documentation for that and see what we can figure out. So str toll. Str toll unsigned. Okay, so there looks like there's some different things here. str, oh, so there's this so there's some other versions of this function that I didn't realize, and I can see there's like this U version. I'm gonna guess that's unsigned. So I'm just using the wrong version. So I think if I just put a U in front of that for unsigned, I think we're good. So let's try that out. So let's build it, and if it doesn't complain, then I'm gonna think that we're probably right. And if we do this again, what do we got? We got all ones. Excellent, excellent. So the number is a -1 because that is a that is the decimal equivalent. Now we might want to, if we really want to make this utility kind of like print off other things besides this, then, you know, maybe we should also have the decimal version and the hexadecimal version, as well as the binary version of what we're printing off. So let's kind of clean that up a bit, and then we're done with this. So going over here, we have this number not binary. Let's duplicate that, and this number is inputted, so let's just call it num, and right, because that is the name of it. And then for hexadecimal, it is like 0x, but it's like I think it's like a 0.6 or a 0.8x or something like that. Let's just do printf hex to 8 places. See if I have a shortcut for this yet. Yeah, so did I get that right? Oh, look, I got that right. Excellent. So I got it. Yeah, excellent. So we will print off both the integer version and the hexadecimal version. So des, we'll just say des, and then we'll say hex. All right, so, and then the other one is the binary. We're not going to label that. It's pretty obvious that one's binary. And we still got to do some stuff to clean it up a bit, though, now that I think about it. But let's just try this out and see how it works for us, and then do a little bit of cleanup. So I would like a 0x in front of that, just because I like it like that. So let's go back to where we did this printf and do a, we're just going to put a 0x. Ooh, will that work? Or is that, no, that shouldn't conflict. So it's a little bit weird, but we're just going to add that to the string, just so that it looks a little bit nicer, right? So let's clear, let's go find our build script again, and then let's run this and see how that looks. So excellent, excellent. So now we have the hexadecimal version of the number, the decimal version of the number, and then we have this nice binary print, right? So now we have a binary printf. So the last thing we're going to do before we get out of here is we are going to put this up on GitHub, right? We're going to start putting stuff up on GitHub, right? When we do these little side quests, we're going to throw the stuff up onto GitHub so that, you know, if you want to mess with it, you have a way to mess with it. So let's also put our Twitch URL in here. So Twitch URL, let's put the JMIM demos URL, And let's put git AAC URL as well. And just say, right, just keep, just kind of make this a little bit nice. Written by. Okay. And just do a little thing like that. And then at the bottom, we could also, right, we could be really annoying about it and just kind of throw it in the top and the bottom as well. I would like to just label the sections. So let's label this as includes so that we have kind of a little bit more consistency to the indentation, because right now this is kind of free floating without a section, and it bothers me because I have this, you know, problem with making everything as regular as possible, right? So now this section is kind of smushed up against here, which looks nice because then we can, on the bottom, we can kind of smush up this against here. It just visually it looks nice, so I'm gonna do that. So that looks good. Let's make absolutely sure that while we did our OCD formatting stuff that we didn't accidentally inadvertently break anything. So we're gonna double click this and see if that works. And yeah, so we did break some stuff because we think that this is some type of multi-line comment, and it's not. Though I do like the visual style that kind of gives off, so I'm just going to be more obnoxious, right? So rather than delete that and replace it with a multi-line comment, we're going to do both of them at the same time, just because I like how it kind of like gets your attention, right? So then we're going to go down here, we're going to paste this right down here. Looks great. Great thing that I, you know, tried to make sure it's still compiled in case I did something stupid, because I do things that are stupid all the time. Okay, so now we're going to do a git bash here. We're going to execute the executable ./bin.prin.exe. We're going to put some number in. How about 0x and then you know, ff0000ff, right? So let's give that a shot. See what that looks like. That is what I expected. We got a little bit of wrappage here because I zoomed in a little bit too much, but that is correct. So the first byte, the bytes in the middle, and the last byte, right? So, right, and then what we originally typed, and then what it is in terms of decimal in a signed representation. So I don't know if the signed representation is good. Maybe we should have done unsigned. I don't care at this point. I think that we're done here. If you want to polish up the code on your own time, that's awesome. But I'm not going to. So let's do a git bash here in this folder. And we are going to do a git init on this folder. So git init dot. Okay. And clear. And then git status. Git status. Git add dot. Okay, and oh, sorry, you can't see that, can you? Because it's not on your console. Well, so let me just hit enter a few times so you can see where I did my git add dot, and then we're gonna do a git commit -am, and then, you know, first commit. Or actually, you know, we're gonna say C vid iid 0090. That's actually better. So this is what I typed right here, and then I pressed enter, right? So git commit -am, and then C vid iid 0090, right? Because if you look at the bottom right of the screen, you can see that we're on video 90, right? Okay, so now to get this up on GitHub, we're going to have to log into GitHub. So let me do that off screen. So www.github.com. And we're just going to put that up on GitHub, and then we'll be done with this. So where are we? We are in Heavy Metal Cookies. I'm going to sign out and sign into Kanji Coder. Sign in. Kanji Coder. Password. Okay, so now that I'm in, I'm going to go down here, and we're going to create a new repo, and we're going to call it, we called it bin print, right, for binary print. Binary printf command line utility. Alright, we'll say, I don't know, we might as well kind of throw in our Twitch URL there, right? Advertise ourselves or whatnot. And we'll make it public. And we won't do any of this stuff because we already have the repo ready to go. Create the repo. Okay, cool. So now we have a little URL for this. I'm going to save this in my notes. So this is the binprin git URL. Binprin git URL. And I'm going to invite a collaborator because I'm logged in as Heavy Metal Cookies on my machine. I don't want any headaches by having multiple users using the same terminal. So what we're going to do is we're going to go into the settings of this project and manage the access, and we're going to invite our other account. So that's how we're going to do this. We're going to invite a collaborator, and we're going to invite Heavy Metal Cookies. And that's me. Add Heavy Metal Cookies. Alright. And now that they're invited, we're going to have to log out of here. We're going to have to sign out. And then we're going to have to sign in as our other account. So I'm going to have to put this off screen. So the reason why I have to sign in as the other account is that when I take the email notification, the email invite, if I'm not logged into the correct account, the invite link does not work properly. So log into Heavy Metal Cookies, tab, oh, nope, I'm gonna just say my whole password. Great, now we know what letter it starts with. Luckily, my password is quite a lot of letters, so I'm not worried. Sign in. My password's complicated enough that I often type it incorrectly, even though I know what it is. Okay, so now that I'm logged in, I'm going to go to my email, which I'm also going to keep off the screen, so sorry if you want to see the tutorial of how to do email. Probably not, because if you're looking at a code tutorial, you probably already know how email works, right? Okay, so view invitation. Okay, so actually, let's go back one. So let's actually go look at how that works. So we're in my email, right? And it says Kanji Coder invited me to binprin, and we see this view invitation link, and all we gotta do is click that, right? And from here, I believe we need to, yeah, we need to accept, right? So we have to click it, but then we have to hit accept. And now we have access. So now that we have access, let's close our browser. And do a git bash here. And open this up. And we're going to do git status. Okay, git remote -v. That will be nothing right now. Git remote add, and we'll do GitHub, and we'll take the remote URL. So let me just take that from my clipboard here. I'm gonna right click, paste, close off the quote marks, hit enter, and then if I do git remote again, git remote -v, hit enter, we can see, hey, look at that, we got our remotes. Excellent. So I'm gonna clear this. And then I'm going to do a git push, GitHub, and then master, right? We're going to push it up there. And after that, it's up there. It's up there if you want to take a look at it. So the next part is, if you see the tiny URL was currently configured for the previous project. So let's see if we can make another tiny URL for this specific project. So I'm going to close this, and I'm going to open up the browser. I'm going to go to www.tinyurl.com, and we're going to see if we can get a URL, a shorthand URL, that will take us here, right? So let's take this, and the first try that would be best is if we can get binprin to work. Binprin, right? I have no clue if that's going to work. Let's give it a shot. Binprin can't be created, so the first thing I want to do is see what that is. One of these days I'm going to get a virus doing this, but let's just try that out. I wonder what that is. Maybe I shouldn't do that, because what if this ends up being porn, right? Yeah, maybe I shouldn't do that. But yeah, so we're going to have to choose something else, unfortunately. So, I don't know, kanji coder. So how about KC binprin? Huh? Or how about KCBP? I don't know. Let's try that. Let's just keep on trying some things until we get something. Let's just try that KC binprin for kanji coder binprin. Okay, so it's not the best tiny URL, but it'll work. So I'll just make a note of this in my notes. So binprin tiny URL, binprin tiny URL, and then binprin tiny, paste that, and then we'll just put it up here. We're gonna put it in right, so we're gonna put it right there, and we're gonna have to resize this because now we don't quite have the room for this anymore. Can we just move this to the top so we can put this above everything? So this is, yeah, we could probably move this up. So let's just move this up. There we go, and then we can kind of like overlay that there, and then we don't have to worry about, there we go. So there. So now it's on the screen for you to observe. Let me shift that around, and let me lock this, because that's not right. Lock that down. Okay, yeah, cool. So if you want to check this out, you can go to my GitHub, kanjicoder/binprin right here, and you can take a look at it. And I made a note that the video ID is number 90, if you want to check that out. And what else? I don't know. I mean, that's it, right? So the URL's there for you if you want to check it out. And I'm going to stop on the title screen, just because, I don't know, I want this to be easy to upload to YouTube. So